Welcome to the fourth International Symposium on Multidisciplinary Studies and Innovative Technologies. Due to COVID-19, we are holding our symposium virtually. I hope this epidemic will end as soon as possible. Let's start this session. First paper belongs to Hanin Ali Sahib is here. Hanin Ali Sahib. Hanin Hadi. Asiful Hakwe. Are you ready?
Yes, Asiful Haq here.
Okay. You can start if you are available.
Okay. Yes, sure. Okay, so let me start.
Okay.
Can you see my slide?
No, I can't see. Share your screen, please.
Okay.
Bottom of the Zoom, yes. Maybe your slide is appear.
Okay. So you can see now?
Yes.
Okay, that's good. Okay, hello everyone. Good afternoon. My name is Mohammad Asiful Haq. I am a fresh graduate from East West University, Bangladesh, from Computer Science and Engineering. My presentation topic is Factoid question answering over Bangla comprehension. So this is an overview of my presentation. First, I'm going to talk about something about Factoid question, then an existing work of question answering system. Then I will talk about our data set and our model architecture, and then result analysis and conclusion. So what is a question answering system? Well, a question answering system is an information retrieval system in which a direct answer is expected in response to a submitted query. It is a man-machine communication device. So if I want to give an example of Factoid question, it would be how much costs a BMW, or who is the president of Bangladesh? This is the Factoid question. In fact, the title of this slide, what is Factoid question, is itself a Factoid question. So we can say Factoid question as questions that have a short answer, typically a noun phrase or a simple verb phrase. In Factoid QA, there is usually only one or at most a few correct answer to a given question, and the answer is most cases a single word token or a short noun phrase. Now, there are a lot of QA system in English language. For example, S. Wang et al. They reviewed both used dataset and another neural network engineering to address their machine perception. They also used the pointer net model. They proposed two different ways to apply the pointer net model, a sequential model and a boundary model. However, their system had a low performance in who type of questions. S. Reddy et al., they built a conversational QA system where their machine was able to answer a sequence of questions that appear in a conversation. It shows the answer highlighted with the equivalent proof in the passage, which helps to know the location of the answer. Using a large dataset, they announced and compared the existing system with their own dataset, and they called it conventional question answering, or in short, COQA. Now, there are not a lot of work has done in Bangla QA system. In Bangla Factoid question answer, or in short BFQA, they used a pipeline architecture having three components: question analysis, sentence extraction, and answer extraction. As there is no Bengali corpus available for the QA research, they built their own corpus. To build corpus, they took 14 documents from the geography and agricultural domains, which were acquired from the Wikipedia. It has a total of 184 factoid questions. Also, a short space-based QA framework is created by Monisha et al., where it gives appropriate response of just those queries which are identified with the specific college, Shahjalal University of Science and Technology, in short from SUST, SUST. But unfortunately, it is a closed domain system. So our contribution is that we built a Bengali question answering system that will help to retrieve answer from any types of Bangla documents and get the exact answer. It will add a new dimension in Bangla QA system. Firstly, our proposed system is an open domain QA system. It can contribute the answer of any question if the topic or document related to the question are fed. Here, question types are not fixed. So, enormous arrangements of information are required for our task, and we couldn't discover any source. So, we prepared our dataset manually from the scratch. While trying to conquer the issue of the dataset, we choose broadly read public newspapers, books, sonnets available on the internet as assets and picked messages from different themes. Now, our gathered information is a blended type of regional canonical style and standard canonical style. There likewise are numerous unfamiliar words written in Bangla structure, which actually don't contain any Bangla importance. Now, in our dataset, we found out that maximum question and the text span have a lexical match between them. If we can see the text span, a group of policemen investigated the house and dot dot dot, and the answer is police. So we can see the policeman and police. There are some lexical match between them. On my right hand side, we also notice that the same answer could be used in several questions. For example, who is Narendra Modi, or which country's prime minister is Narendra Modi? Both of these questions can be answered by the Prime Minister of India. We found out that a particular question has several answers for a given text span. For example, who has been observed to criticize Washington Post? The answer could be Prime Minister of India or Narendra Modi or the Prime Minister of India Narendra Modi. Three of these answers could be found in the text span. Some answers are presented by numbers like age, number of people, mass area, weight, height, etc. And this is called the counting. And also some answers need some words to be inserted or to be deleted from the text span for being accurate. For example, here the text span says the corona fear not only affected the share market, but it also affected the money market. The answer is in the share market and the money market. So we have to delete the part not only but also and add and word to make the answer. Now, here are some statistical information of our dataset. Our dataset contains about 1,676 paragraphs, and we made approximately 8,000 questions from there. There are about 1,370 paragraphs in our training dataset, and each paragraph contains 12 sentences on average, and about 6,000 questions were made from those paragraphs. There are about 306 paragraphs in our validation dataset. There are each paragraph contains 12 or 13 sentences on average, and we made about 238 questions from those paragraphs.
Nah, lama.
Now, this is the model architecture. The general structure of our QA framework is introduced in this figure. Now, I would like to explain the figure. At first, to get the vectorized representation of the question and the respective documents, they are passed through the word embedding model here. And we have provided a pre-trained word to vector file with 39 million Bangla words, where each word has a 300 dimensional feature. Now, not all part of the documents are important, which uh, the important parts of the document are those which coordinated with the questions. So the questions are being coordinated with the documents to recognize the closeness. That part has done in this section. Similarity based matching on each question in document. So after that, the text document and the document representation of the question are being converged to make the input files of the document encoder here. The document vector representation of the document and the question representation of the documents. This is the document encoder. In the same way, the vectorized questions being used as the input file of the question encoder. Now, inside the document and the question encoder, there are three stacked bidirectional long short-term memory network. We have also used a long short-term memory network with a forget gate, which is GRU in place of LSTM, to witness the different performance of neural networks. Now, each output of the neural network is utilized as a contribution of the following neural network. The output of each neural network is saved and then merged for both question and document encoding. Now, the main objective of our model is to foresee the range of tokens that is the right answer. Now, to anticipate the appropriate response, two essential feed-forward neural networks are utilized, here and here. The merged output of both encoders is used as the input of these two feed-forward neural networks. Now, one neural network predicts the beginning score of the appropriate answer, which is this one, and the other predicts the end score of the appropriate response, which is this one. As there are some reliance among words, this is the reason one neural network is capable to foresee the appropriate response from the beginning and the other from the end. This likewise builds exactness. This is the methodology. What I have explained here is written in this slide, so I'm going to skip this. Now, this is the implementation environment where we ran our model. The CPU was Intel Core i7, 2.2 gigahertz. The RAM was 16 gigabyte and virtual RAM is 6 gigabyte, and the GPU was NVIDIA GTX 1060. Now, when we ran the model, we tried to trace the hyperparameter, which is learning rate, dropout, and number of layers. So as from this chart, we can see that the best validation F1 score is 92.16% with exact match of 76.8% for learning rate 0.001 with a training loss of 1.8. In here, we tried to find out what would be the best dropout, and the best dropout is 0.3. Here we tried different number of layers, but the best number of layer was 3, where it shows 92.616% of F1 score. Here we tried out basic LSTM and GRU with our traced-based combination of hyperparameters. We tried two types of neural networks, LSTM and GRU, with learning rate, batch size, and dropout, and layers as hyperparameters, and between them LSTM showed a higher F1 score, 92.16, while GRU showed 91.58. So for LSTM, F1 score is 92.16 and GRU it is 91.58. LSTM showed exact match 76.8%, while GRU showed 76.31%. So our best found neural network hyperparameter combination is number of layer is 3, learning rate is 0.001, and dropout is 0.3. So in conclusion, we can say that LSTM performs better in terms of question answering systems, and we were able to achieve a significant accuracy in Bangla question answering system. And we also faced some problems. The problems are that QA system finds very difficult to deal with different rewordings in question and documents. It's difficult to infer information that is not explicitly mentioned in the text, and we could have showed better result if we have large data set. Now the solution of this problem could be that the application of textual interface inference and knowledge bases and improving the data set in number. So that is all from my side. Thank you very much for listening to my presentation.
Thank you very much for your presentation. Dear participant, do you have any question about this article? Okay, no question. Thank you again. I wish you success in your career. Hope to see you, Mr. Asiful Haq.
Thank you very much.
Okay. The other.
Sorry, do you hear me? Sorry. Do you hear me?
Yes, I can hear.
Could I note something? Could I present earlier than the scheduled program because at 3/4, yeah, at 3/4 I should have left the meeting.
Okay.
At 2:45 p.m. I should have left the meeting.
Okay. Okay. You can present your presentation after Muhammad El Abbas. Okay.
Okay. Okay. Thank you.
Muhammad El Abbas, are you ready?
Yes, I am.
Please, you have 10 minutes.
Okay.
More at most. Okay.
Okay, no problem.
Okay. You can start, please.
Did the screen show up?
Yes, we can see your screen.
Okay, my name is Muhammad Abbas. I'll be presenting the impact of collaborative research, a case study in a developing country, on behalf of myself and my professor Samer As-Saab for the Lebanese American University. So what is collaborative research? Collaborative research is defined as researchers working together to achieve a common goal of producing new scientific research. However, there are different types of collaborative research. The three most defined ones are institutional, national, and international. In institutional, it is individuals or researchers from the same university, same country, but they might be from different departments. National is individuals from the same country, but different institutions, while international are individuals and researchers from different countries, different institutions, and possibly different departments, which would lead to international interdisciplinary research. Now, collaborative research in particular has seen a rise or an increase in collaborative research because of changes in technology, which allowed and facilitated communication without being physically present with the person, such as this Zoom, and changes in geopolitics in particular. Currently, due to COVID-19, there has been an increase in collaborative research between China and the US, two countries that have struggled politically before. However, researchers have transcended the geopolitical struggles and have begun to collaborate more together, share data more together, and arrive at more conclusions that aim to advance sciences. So, because of collaborative research and the increase in collaborative research, there has been an increase in attempts to study it and quantify it and qualify it. So two claims emerged. The first one, there's a positive association between collaboration, number of citations, and the quality of publications. The second claim, there's a that low-impact countries, often developing countries, stand the most to benefit from international collaborations, primarily with high impact countries, often developed nations. So what both of these claims are saying, that there is a positive or global positive impact for collaboration on an institution, but institutions that are in developing countries stand more to benefit when they collaborate with institutions from other countries. How true are these statements is the objective of this study. We first required to select our sample or the university we will be studying, and we decided to select our own. That is because it has no PhD programs and it produces relatively low amounts of master degrees annually. So the research is primarily driven and conducted by faculty members themselves. So one could argue that the quality of the publications or the standard average of publications will be that above ones that are produced by PhDs or master students or postdoctorals. Now, when assessing the university, the metrics and indices and venues that will be considered are of vital importance, because the Leiden Manifesto, which decided how science of science, or how the assessment of quality research has to be conducted, said that there must be a variety of indicators to be used when assessing scholarly research to actually have a robust view of how good or bad that research is. So the metrics we will be using is citation counts, views, and the journal impact factor, GIF percentile, where the publication has been published. As for the indices where we will source these metrics, it is Scopus, Web of Science, and Google Scholar, while the venues that we will assess are primarily articles that appear in Q1 and Q2 publications in 2019. Q1 and Q2 are in particular interest. It's because their perceived prestige of publishing in such journals, people will opt to argue or try to collaborate with more individuals in order to enter such prestigious journals. In 2019 in particular, it is because our institution saw an uptick in their total published works and subsequently in their total number of collaborations. Now, the data set that these restrictions generated is 117 articles, 6 of which are single authored, 14 of which are institutional collaborations, 22 are national collaborations, while 75 are international collaborations. In other words, 99.5% of all publications in Q1 and Q2 articles made by LAU are collaborations. Even more so, 68.4% are international collaborations. These collaborations spread across a spectrum of categories. The most notable category of interest for our study is the life sciences and medicine category, because it formed 44.0% of the international collaboration, while only 35.7% of the institutional collaboration. Now, if you look at this table, we will see that we have the 3 types of collaborations and their respective values in the metrics. Now, if we look at the first observation, we can see there is a significant difference between the national collaboration metrics and the institutional international metrics. Now, if we look at the average GIF percentile in specific, we can notice that there is the international collaboration is 8.2% greater than that of the institutional collaboration. However, if we look at the average citations, we will notice that there is a 4% greater value of average citations between international and institutional. But if we look at the types of citations they are receiving, we can actually note that the international collaborations on average have 5% greater self-citations than institutional collaboration, which could justify the disparity in average citation counts. As for viewership, we could notice that we should note that viewership is a necessary condition for ethical citation, because you have to view an article in order to read it, understand it, and then cite it in your work. So this is a valuable metric to look at, because it would mean that the citations received are citations that admit the quality and the contribution of the paper they're citing. Now, the number of citations, number of views, garnered by institutional collaboration is almost double that of international. However, this disparity could be somewhat justified by the publication norms and trends of life sciences and medicine, which caused this disparity. Now, so by using citations as an impact metric, we found that institutional collaboration yield comparable benefit to international collaborations, while national was detrimental across all metrics. While these findings rely on a small data set from LEU, they are pertinent to the institution itself, they do contest the claims made in 2, as in we collaborating with ourselves in the institutional collaborations have produced research of comparable quality to international collaborations, but our findings do reaffirm claim 1, such that there is a positive correlation between the number collaboration and the number of citations, views, or general impact factor, which is a stand-in for quality of a publication. We believe that further investigations in this narrative or in these claims will show that our findings could be generalized, and we will continue to contest the claim number 2. Thank you for listening. If there are any questions, I would be happy to answer them.
Thanks for your presentation. Dear participant, do you have any question for this article? Okay. Mr. Mitro, are you ready for your presentation? Ioannis Mitro, are you ready for your presentation?
Can you see my screen?
No.
Okay. Now?
No, not yet.
Now?
Yes, yes.
Okay. Let's proceed to the presentation. Hello, everyone. I am.
You have 10 minutes at most, okay?
Okay, thank you.
Okay.
Hello, everyone. I am a graduate student of Electrical and Computer Engineering, University of Thessaly in Greece. Our subject of concern of discussion is adaptive cruise control, which was modeled with a scenario we designed and the control performance improvement using the MATLAB tool. The goals of this study were to investigate the advanced driver assistance systems and to evaluate the systems and controllers' functionality with the use of model predictive control. We intervened to the controller's properties for the optimization of the system's performance, and afterwards we selected the appropriate controller properties for an optimized cost that ensured driving safety and gave us efficient results. All these results were in compliance with driving safety standard ISO, were followed by the compliance of this safety standard ISO, which was the 15622. And the system we investigated was in this report was adaptive cruise control. Okay, let's see the structure of our report. We will introduce the levels of automation due to according to the Society of Automotive Engineering, J3016. We will then proceed and see some applications of the automotive vehicle applications and the obstacles adopting these, as well as the advantage of them, and we will see that we'll finally see the methodology we used for our adaptive cruise control system using sensor fusion. As referred previously, at level 1, at level 0, there is no automation. We then proceed to level 1, where the driver assistance is provided by only one system, which is our adaptive cruise control system. We then proceed to level 2, where the driver is responsible for the cruise control of the vehicle, and the concurrency of two advanced driver assistance systems is detected at this point. Traffic jam assist is an example of this level. We then we jump to level 3, where the responsibility belongs both to the driver and the vehicle, with the driver being ready to take up driving when a warning appears. And we finally have two more levels, which are level 4 and level 5. At level 4, we have high level of automation, and the vehicle operates more independently, executing lateral and longitudinal dynamic operations. And level 5, full automation is detected, is observed, and the vehicle is capable of executing all the operations mentioned above without geographical restrictions, which means that in specific driving case scenarios, there is full automation of the vehicle. Okay, so we should refer to some vehicle applications which are advanced nowadays. One of them is the automated parking valet, the full, and which provides some type of full driving automation with the driver being able to intervene when able. Some advantages of the automated vehicles are the reduction of human deaths caused by human factor car accidents, the reduction of unhealthy air gases, of the unhealthy air gases percentages caused by traffic jams, the reduction of fuel consumption, as well as the reduction of driving time. However, there are some obstacles adopting this use of automated vehicles, which are as obvious the buyer's acceptance, the safety guarantee in stealth pursuit cases, the manufacturer's reliability guarantee, as well, and of course the high technology and selling cost. At our paper, automated driving toolbox of MATLAB was used in a pre-built model predictive controller, and the cut-in, cut-out driving scenario was designed according to bibliography. The coordinate system was the XYZ for the environment and the vehicle, and yeah, and the same coordinate system was used for the sensors, and for the grid pixel discrimination, coordinate system XY was used. The sensor technologies used for the vehicle environment in advanced driver assistance systems are the radar and camera, which were also used in our analysis. Some other technologies are the LIDAR and the ultrasonics technology, and the GPS, which is already known. The sensor fusion provides the following advantages, which are the efficient data processing, the evaluation of data giving an accurate signal that will warn the driver to act, multi-range detection capability, and of course there is a creation of a memory type for the sensors. The model predictive control acts as follows. The car has a beginning point and an end point, and it should ensure that it will securely handle all the possible maneuvers and obstacles. There are two dynamics separated in the automated vehicles, lateral and the longitudinal. The longitudinal behavior is modeled by a first-order system, and the lateral by a 3 degrees of freedom bicycle model. In this case of model, longitudinal movement, lateral movement, and yaw movement of the vehicle were taken into consideration. Here we have a representation of the 3 degrees of freedom bicycle model for our vehicle dynamics, which was used to understand the structure. And we move on to the explanation of the model predictive control concept, which was used for our study. The prediction horizon window P is the number of the future control intervals that should be predicted by the model predictive control during the optimization at the current control interval K. The control horizon indicates the moves of the manipulated variables that should be optimized within the time interval K. The sample time is a parameter that indicates the time interval that the output of the model is being generated during the simulation and the update time of its internal condition. And all these are being understood from this representation of model predictive control, where the output reference trajectory, where the predicted output uh, tries to aims to follow the reference trajectory, as we see from the red and the blue line, as presented here. Under, of course, all these is accomplished under some defined constructions which are followed by the driving safety standard. The control system being shown previously, as we mentioned before, was the determination of future control input U in order the output Y to follow the reference trajectory. The main features of the multi-variable model predictive control are mentioned below. It's a dynamic model of the process, a cost function J in the horizon, an optimization algorithm that use the control input and optimize these results by the minimization of the cost function J, and some advantages in comparison with the classical proportional integral derivative control are that there is an optimization capability within the current time interval repeatedly, maintaining data for future control intervals. Mm, it can also handle multiple manipulated variables and output variables under specific defined constraints, and there is, of course, a great interest in automated driving applications recently due to the improvement of the vehicle response. The cost function we are interested in is referred below. The operation of our control system for the adaptive cruise control is the control of the velocity for the movement with the desired velocity set by the driver, the distance control from the leading vehicle for the maintenance of this safe distance. So if the relative distance from the leading vehicle is greater than the safe distance, there is a need for vehicle velocity control in order to acquire the defined driver set velocity. Otherwise, if the relative distance is less than the safe distance, then the safe distance needs to be maintained at safe levels, and the safe distance is defined from the equation showed here. Uh, Time gap equals the clearance, which is the distance between the two vehicles, the preceding vehicle and the leading vehicle, divided by the longitudinal velocity Vx. So, the adaptive cruise control problem using model predictive control case was the solution of an optimization problem, the minimization of the steady state error, which was uh, which is the output velocity minus the reference velocity, the absolute value of this subtraction. The relative distance should always remain less than the safe distance, and the advantage is that we have a full throttle or brake press for the collision avoidance under the constraints of acceleration at the interval -3 to 2 meters per second. Uh, Here we have some representations, some responses for different coefficients of friction that we investigated. As we see from these representations and responses, in all cases, a safe distance was the actual distance from two vehicles remained at some stable levels and safe levels, of course without any collision, so we avoided the collision, and the velocity response also kept a satisfying response. Those responses are for different prediction horizon values that were tuned in order the model predictive controller to have an efficient operation. So, proceeding to the ego velocity response of the vehicle that we're interested in, we see that for different prediction horizons and for different properties of the controller were tuned, uh, which were tuned, sorry, uh, for the from a parameter called controller slider, different overshoot percentages and rise time were obtained. So we selected these values of prediction horizon and controller slider that gave us the lowest overshoot percentage without being interested in the rise time. We wanted the comfort driving, and so the lowest overshoot percentage ensured this. These results are listed in the following table, where we see that for prediction horizon 30, in all different cases of velocities, in all different velocity cases, for our driving scenario, zero overshoot percentages were obtained. For the controller, we should also mention that increasing the controller's rider value, more aggressive behavior was yeah was was seen, and so the appropriate selection was done through an investigation. Finally, we should conclude and say that the control of the lateral and longitudinal behavior at the advanced driver assistance systems was done, was implemented. So we evaluated the longitudinal velocity output response features of the vehicle for the adaptive cruise control system, and we controlled the normal operation of this control system for various friction coefficients and selected some appropriate values for the model predictive controller, ensuring overshoot percentage and rise time for the comfort driving. Thank you for your attention. If you have any questions, I would be grateful to hear them. And I'm sorry about some syntax errors that you saw because I had the pressure. I have some military duties and I hadn't got the time to prepare them efficiently. Thank you.
Thank you very much for your presentation. I wish you success in your career. Hope to see you. Dear participants, do you have any question about this article? Okay, no question. The next paper belongs to Ketut Purnavan. Are you ready?
Okay, I will prepare my presentation. Thank you.
Okay.
Okay, just waiting. I
You
will share
can
the
start.
screen. Okay. Can you see my screen? Just waiting.
Yes.
Okay. Okay, thank you for the time. My name is Iketut Adi Purnawan from Institut Teknologi 10 November Surabaya, Indonesia. Now I am presenting our study about the optimal electromyograph vector selection for classification of normal and four-stroke from hand reaching movement. This research conducted by 4 people shown on the screen. The background of this research is from post-stroke paralyzed patients who have to deal with severe muscle damage and not be able to perform daily tasks, lead them to a crisis in quality of life. Rehabilitation with the right method will reduce more damage and improve their quality of life. On other side, we know that some research use EMG signal as a muscle functioning rehabilitation. This is often an interesting research for us to explore the usage of EMG signal to help post-stroke paralyzed patients. But later we found that EMG signal is kind of non-linear, non-stationary, and similar in time and the frequency domain. Those characteristics make EMG signal is harder to recognize and classify without an automation system. On other side, we know that some research uses EMG signal. Sorry. Okay. Therefore, we want to build an automation system to recognize and classify the EMG signal. We found that EMG signal classification system heavily depend on the number of the feature used. To have the most accurate EMG signal classification system, we need more feature extracted. The problem continues here. More feature extracted mean more computational resource consumed and more processing time needed. Meanwhile, when building a complex system, we have to keep everything as efficient as possible. In order to save the computational resource and processing time, we propose an approach to find the most optimal feature selection to gain accurate EMG signal classification between normal and post-stroke patients. We want to find the most optimal feature to use in classification system that can perform with high accuracy even only a single feature use. This is what we propose we try to find. The first is EMG or integrated electromyograph. EMG is the sum of absolute value of the digitized EMG signal. Second, simple square integral. Simple square integral use the energy of the EMG signal as a feature. Third, mean absolute value. Mean absolute value, it is similar to EMG with use as an onset index. Modified map type 1. Map 1 is the extended version of map that use waiting window function as the improvement of map robustness. 5. Modified map type 2. In map 2, the continuous wedging windows. The continuous wedging windows function is used to improve the smoothness of wedging. 6. Root mean square. Root mean square is one of the number common feature that widely used in prevision signal. Variance of EMG or VAR. VAR capture the power of EMG signal with calculating variance of digitized EMG signal. 8. Wavelength. Wavelength defined as the cumulative length of EMG waveform over the time segment. 9. Different absolute standard deviation values. 10. Jot activity, a statistical parameter that represent the signal power and the variance of a time function. 11. Jot mobility, also a statistical parameter that represent the mean frequency or the standard deviation proportion of the power spectrum. 12. Jot complexity, also the part of jot statistical parameter that represent the change in frequency. 13. Autoregressive. Autoregressive describe its EMG signal sample as a linear combination of previous EMG samples and white noise error term. Selection criteria. The most optimal, the criteria selection of the optimal feature should have a high significance to the classification accuracy. Therefore, even with a single feature, we can do the classification task. How did we weight the accuracy? It is using the tree-based classifier, particularly the extra tree classifier. We weight the accuracy in 3 steps. The first one is building a hypothetical extra tree forest. Second, compute its feature important to the accuracy. The last step is visualizing and comparing the result in a graph. Dataset. The dataset of this research is gathered from 12 healthy subjects and 13 post-stroke patients who did instruction of hand-reaching movement with egg electrode attached to their muscle. Where the electrode put is in this egg muscle. We can see on the figure. The experiment conducted in 3 phases. MG signal pre-processing, feature extraction and labeling, then classification, accuracy, evaluation of each feature. For the data processing, what we did was clean the data from inconsistent name structure using Lipinstein algorithm. It's worked by find the difference of distance between the name different and the data as shown on the flowchart. After that, we did the normalization to form an MPC visualization. From the figure, we can see there is a yellow color is a signal of a normal patient, and then the blue color is a stroke. There is a 8 muscle present. The feature calculated with the given formula as shown as previously. This is the sample of calculated feature from 1 electrode. Due to the limitation of the presentation slide, we are not able to show all the extracted feature. In this, we only three feature: root mean square, simple square, integral, and wavelength, and only 5 subject. The feature that have been extracted then go to the process called labeling. At this point, we perform the extra tree classifier in recursive process. Each of feature will be identified as a differentiator by labeling them with 1 or 0. The result of labeling process then visualized through a graph. On the y-axis is the name of each feature, and the x-axis indicate each feature important to the accuracy. Here, what we found as the result of the research. First, based on the graph, root mean square yielded the highest significance to the accuracy of classification, and followed by simple square, integral, and wavelength. After a thorough analysis, the characteristic of root mean square as a feature that use amplitude took advantage in classification between normal and post-stroke patient. Root mean square also feature used in AMG signal processing due to its characteristic that efficient and fast processing. Conclusion. Therefore, the future AMG signal classification task of normal and post-stroke subject that need a high accuracy but with limited resource can employ root mean square feature only, or its combination with simple square, integral, and wavelength. Future work. The result of this study supported our continuing research about the implementation of the EMG signal to assist rehabilitation for post-stroke paralyzed patient. This end of presentation. Thank you for listening, and if there is a question, I will be happy to answer. Thank you for your time. Thank you.
Thank you very much for your presentation. If there any question, dear participants, you can ask Mr. Ionis, pardon, Mr. Ketut Purnavan. Okay, no question. Thank you again. I wish you continued success in your career. Hope to see you.
Thank you.
Is there any participant with a paper in this session? Okay. Hanin Ali Sahib, Hanin Hadi, and Haydar Makkenama didn't join this session. Let's wait for a while.